Right, we're just doing a couple of extra examples of differentiating using rules. So these questions come from Mindful Math, exercise 6.4, page 226. And right, so I would give them a go first, and then you can look at my solutions. So we've got a derivative here, we've got a variable in the denominator, we've got a problem. There's more than one term, so I can't divide out. So we're going to have to factorize the top over here. So I'm going to have the derivative. Okay, and if I try to factorize that, what we're going to have, well, we can take out a common factor of 2x. So if I take out 2x, okay, then I'm going to be left with x squared plus 2x times x squared plus 2x times what gives me 2x squared by x. 2x times what gives me negative 24x, so that'll be negative 12. Right? So I'll get 2x, x squared plus x minus 12 over 3 minus x. Okay? We can factorize that trinomial some more. I still haven't differentiated, so the instruction still stays there. So I end up with the derivative. I've still got to leave that notation there. So it's going to be the derivative of 2x, x squared plus x minus 12. What does that factorize to? It's going to be x, okay, times out and get negative 12 and add and get 1. So it's going to be plus 4 and negative 3. Okay. I want to cancel. The moment I've got 3 minus x over there and I've got x minus 3 over there. So I want that 3 minus x to become x minus 3 so I can cancel. So we're going to take out a negative. Essentially, okay, so I take out a negative. When I take out the negative, that'll become x minus 3, so I haven't changed the value of it. It's negative x plus 3, which is the same as that. But now I can cancel. As soon as I cancel a variable, I should write this restriction, or x can't be 3. Okay, so then now I still can't quite differentiate. I've got to simplify that first. So I get the derivative of 2x squared plus 8x. That's now in differentiable form, and the derivative of 2x squared plus 8x is going to be equal to 2 times 2 is 4, take away 1 from the exponent, so I'm going to get 4x plus 8. And there's the final answer. Okay, check that, see that you're okay with that. Right, the next one, it says go find dy dx. Okay, let's just move that up a bit. Okay, if y is equal to, right, next is question 20. It says determine dy dx if y is equal to 2x squared minus root x plus 5 over root x. Right, if you haven't tried it, give that a go first, and then you can come and watch the solution. So now you're dividing, you've got a problem is you've got a variable in the denominator, okay? But you're dividing by a single term, so factorizing is not going to help you. And remember that if you had 7 plus 14 over 7, all over 7, it means the same thing as 7 over 7 plus 14 over 7, which is equal to 1 plus 2, which is 3, which is the same answer you would have got if you got 21 over 7, which is 3. So I'm going to divide each bit, single term, I'm going to divide that out over there. So I get y is equal to, well, we're going to have, let's get things into, get rid of third form first. So it's going to be 2x squared minus, well, square root of x is the same thing as x to the half plus 5. Okay, all over x to the half. And so now dividing by a single term, we can write that as y is equal to 2x squared over x to the half minus x to the half over x to the half plus 5 over x to the half. Okay? Right. Now when we're dividing powers, we subtract the exponents. So 2 minus a half is 4 over 2 minus 1 over 2. 4 over 2 minus 1 over 2 is 3 over 2. So it's going to be 2x to the 3 over 2. This will cancel out, so you'll be left with 1. I've got to move that power up, so it'll become plus 5x to the negative a half. Okay. Right, and now we say that the equation is in differentiable form, so now I can differentiate it. So my notation is going to have to change. What's your notation? So that's y, but now I'm going to differentiate, so that's y, then dy dx, the derivative of y with respect to x, will be equal to, now apply your fundamental rule, and 3 over 2 times 2, 3 over 2 times 2, okay, is going to be equal to just 3. Okay, so I get 3x, 3 over 2 minus 1 is 3 over 2 minus 2 over 2, which is a half. The derivative of a constant function is 0. 5 times negative a half is negative 5 over 2. Negative a half minus 1 is x to the negative 3 over 2. Okay, and you can stop there, okay, unless it says to you, leave answers with positive exponents. Which this one doesn't, but just to show you, then I'd say dy dx is equal to 3x to the half minus 5 over 2. That power would move down. Okay, sorry, I've lost you there. Dy dx is 3x to the half minus 5 over 2. That power would move down. When I move the power down, the sign of the exponent changes. So if they said leave your answer with positive exponents, that would be your solution. Okay, so remember, a single term, you divide out, always get change from third form to exponential form. Right, the next question we're doing is question 22. Okay, now normally we get a situation like this, where they say, normally we express y in terms of x's, so you'd have y, for instance, is equal to 3x squared plus 2x to the 5, and then we differentiate y with respect to x, so you get 6x plus 10x to the 4. That's the kind of the standard form, but there's no reason why we can't do this. Here, we've got it's swapped around. Here it is dy dx, that's what normally the case is. This is dx dy. Okay, and just like here we've got y on its own and we expressed it in terms of x, here we've got x on its own and we express it in terms of y. Just like normal, first thing I'm going to have to do is simplify that. In other words, I'm going to have to square out. Always simplify before you differentiate. So if I do that, I get x is equal to 4 to the negative 1. Well, 4 to the negative 1, we may as well make it a quarter. Okay, y to the 4. Okay, minus, now be careful of this kind of squaring. When you're raising a power to another power, you've got to multiply out, so negative 1 times 2 is y to the negative 2. So when you square that term, you're going to get minus y to the negative 2. Times them together, and then times by 2. So you're going to have 2 times y to the negative 1. Remember, when I'm squaring a binomial, okay, times by 2, and times them together, and then times by negative y, okay, to the 1. And when I'm multiplying powers, I add the exponents, so you get you've got that negative sign, so you get a negative over there. So you get negative 2 y to that, you add the exponent, so that's negative 1 plus 1. So it's going to be negative 2 y to the naught, and y to the naught is simply 1. So you get negative 2. If I would predict that would be the biggest mistake, is getting the middle term after you've squared this. Go through that again. Okay, so when you raise a power to another power, you multiply the exponent, that does that bit over there, to get the middle term. Okay, you times them together and times by 2, so it's 2 times y to the negative 1 times negative y, which means negative y to the 1, okay, which gives us 2. Add the exponents, y to the naught, negative 2y to the naught, okay, and negative 2y to the naught, sorry, is negative 2 times 1, which is negative 2. Okay, so I get negative 2 as your middle term here. So times those together and times by 2. Okay, right. And then if I square a negative, it becomes a positive, so it becomes plus y squared. Right, and if I simplify that further, because it's still not differentiable, I get x is equal to a quarter y to the 4 minus y to the negative 2. It's a variable, so this one I moved down because it's a constant, but a variable I don't want anything in the denominator, so I leave it like that. Plus 2, I distribute that negative, plus 2y squared. Now we say that this equation is in differentiable form, so now I can differentiate. If I'm going to differentiate now, the notation changes. Normally, like in this one over here, if you've got y is equal to something, we say we're differentiating y with respect to x. Okay, x is the independent variable. Now it's swapped around. So now I'm going to differentiate x with respect to y. What's on its own always goes at the top. What's on its own, okay, always goes at the top. Okay, so you use the fundamental rule of differentiation. 4 times a quarter is just 1. Okay, so it's going to be 1. You don't have to write the y in, and I get 1y cubed. Here, negative 2 times negative 1 is plus 2, y to the negative 3. Derivative of a constant is 0, and the derivative of 2y squared is going to be 4, take away 1, y. So there is your final answer. Okay, you don't need that 1. It's y cubed plus 2y to the negative 3 plus 4y. I hope I haven't made any careless mistakes in any of these. So I was just checking, and I went over my work, and I realized I made a deliberate error in this question. I was hoping you'd pick it up. Okay, and this is just a careless mistake. Negative times y squared, I don't know why I put the hell I put 2y squared, but it's going to be equal to, so this bit over here, and negative times y squared is negative y squared, and then if I differentiate that, I get negative 2y. Apologies for the error. Right, and I also made a deliberate error in question 16, to see if you're paying attention. So I forgot about that negative on purpose. Okay, so then when I cancel, I select that negative, so that negative goes up here, so it becomes negative 2x squared plus 8x, which is a derivative of negative 2x squared minus 8x, and when I differentiate that, I should get a final answer of negative 4x minus 8. Right, hopefully you spotted my deliberate errors. Right, question 28. Well, the tricky part about this sum is really, and actually for most of these ones, is getting the equation in differentiable form. Once you've done that, then it's pretty easy. So, if you look at it, you're not really going to know what to do, but the only thing that kind of looks like a possibility is to mess around with that. So I'm going to say that becomes the derivative of the cube root of, well, x to the negative 1 is the same thing as 1 over x. So I change that x to the negative 1 into 1 over x. Okay. Plus 2 divided by x cubed plus 2x to the 4. Okay, so now the next process is, still can't do much here. I'm going to get a common denominator with that bit over there, go get a common denominator there in that numerator, and so I end up with the derivative of the cube root, or 1 over x plus 2, the common denominator is x, 1 stays the same, 2 over 1 will become 2x, so it will be 1 plus 2x over x, that's just that bit over there. Now instead of having a divide sign, a line like that, with a layered fraction, I much prefer working with a divide sign, so I've done that. Okay, this will still be over that, and it's going to be divided by x cubed plus 2x4, and if it's a fraction, I always prefer to put it over 1. Right, so now how do you divide fractions? You tip in times, so I get the derivative of the cube root of 1 plus 2x over x times by 1 over, and I can factorize this by taking out a common factor of x cubed. So I've got x cubed 1 plus 2x. Okay, and now this is very nice. What happens? The 1 plus 2x cancels, so I'm left with the derivative of the cube root of, well, at the top there's just a 1, at the bottom is x times x cubed, which is x to the 4. So still not in differentiable form. Okay, so I've got to move that x to the 4 up, okay, which is going to become the derivative of the cube root of x to the negative 4. Okay, I'm still not in differentiable form because I've got a third, so that's going to become the derivative of x to the negative 4 over 3, and now I can differentiate, so I drop the dx all the way along the sum. I've got to keep that dx notation because I haven't carried out the instruction. Now I'm carrying out the instruction of differentiation, so you'll get negative 4 over 3. X, negative 4 over 3 minus 1 is going to be negative 7 over 3. You can stop there, but if they say leave it with positive exponents, you're going to get negative 4, move the power down, and it becomes negative 4 over 3x to the 7 over 3. Can you see that last bit? Sorry about that. So there is your final answer. Okay, so we had the derivative of negative 4 over 3x to the negative 7 over 3. Okay, after I differentiated that, okay, and your final answer is negative 4 over 3 x 7 over 3. Right, get that down. Okay. Right, the next one, question C2, it says find dy dx if xy plus y is equal to x squared minus 1. Well, what's different about this question is normally you've just been given y on its own first, like say you've been told that y is equal to x cubed, so then plus 7x, and then dy dx then would be equal to whatever 3x squared plus 7, right? So normally they gave you y on its own. Here, what you're going to have to first do is get y on its own. So your first step is you have to always get whatever you're trying to differentiate, this bit at the top, whatever that is, has to be on its own. So in this case, I've got to go get y on its own. And the only way I can get y on its own here is to factorize that. And I factorize that by taking out a y. So if you take out y, you're left with x plus 1. And that's going to be equal to x squared minus 1. Okay, now to isolate y, you can divide both sides by x plus 1. So I get y is equal to x squared minus 1 over x plus 1. And now, to differentiate that, I've got to get rid of the variable in the denominator. I can't just divide separately, so I'm going to have to factorize. So I get y is equal to x minus 1, x plus 1 over x plus 1. So therefore, y is going to be equal to x minus 1. Ideally, you should state that now x can't be negative 1 because of the denominator there. And now I can go differentiate, so I can say therefore dy dx is equal to 1, okay, bearing in mind that x cannot be equal to negative 1. Okay, and that, ladies and gents, is your answer. Right, 2 more to go. Okay, so C3 says you're given 4t squared minus 2tr plus r minus 1 is equal to 0. The question says show dr dt is equal to 2. So what's your objective? Well, whatever's at the top here, which has to be on its own. So I've got to end up with r is equal to something. Right, so to end up with r is equal to something, let's get everything with an r on the one side of the equation, move everything else to the other side of the equation, and then we're going to take r out as a common factor. Okay, so everything with an r is going to be minus, I'm just going to change the order because it will end up being prettier. So I get r minus 2tr, okay, that's that over there, and I move those to the other side, everything without an r in it, and it's going to be equal to 1 minus 4t squared. So I get r minus 2tr is equal to 1 minus 4t squared. Now what I have to do, I have to take r out as a common factor here. So I get r 1 minus 2t is equal to 1 minus 4t squared. So I get r is equal to, divide both sides by 1 minus 2t, and I get 1 minus 4t squared over 1 minus 2t. Right, so it's division. Okay, I've got to factorize the numerator, and I'm going to say therefore r is equal to the difference of squares, 1 minus 2t, 1 plus 2t, all over 1 minus 2t. Okay, so now, great, that can cancel, so you should say t can't be a half. Okay, so I end up with r is equal to 1 plus 2t, and now I can go differentiate. So now I can go find the derivative of r with respect to t. So therefore, dr dt, that is naught, the derivative of 2t is going to be equal to 2, and I have shown what we were asked to prove. Right, last one I'm going to do with you. You're told y is equal to 2x times 3 minus x, and this is question D1. Okay, D1, y is equal to 2x times 3 minus x, and z is equal to y over 2. Right, z is equal to y over 2. Sorry, just don't check that's clear. And z is equal to y over 2. The first question is find dy dx. So to find dy dx, well, what has y's and x's in? It's that one over there. What at the top must be on its own, so that's good, so that's on its own. But before I start finding dy dx, I've got to get this into differentiable form, and to get that into differentiable form, I'm simply going to times out, so you get y is equal to 6x minus 2x squared. Okay, y is equal to 6x minus 2x squared, so therefore dy dx will be equal to, well, the derivative of 6x is 6, minus 2 times 2 is minus 4x to the 1. So there's your answer. Dy dx is equal to 6 minus 4x. Right, part 2 of the question, so that was part 1. Part 2 says go find dy dz. Okay, so to find dy dz, I've got to be working with that equation over there. Okay, and what I have to get on its own, I have to get on its own what's at the top there. I have to isolate y from that equation. So in this equation, we started off with z is equal to y over 2, but I've got to go get y on its own. Whatever's at the top has to be on its own. To do that, I multiply by 2, so I get y is equal to 2z, and now I can differentiate y with respect to x, and the derivative of z, differentiate y with respect to z, and the derivative of y with respect to z, well, it's linear, so it'll just be equal to 2. So there is your answer over there. Dy dz is equal to 2. Right, the next question says find dx dz. Well, we've got a problem because I haven't got an equation with x's and z's in. Okay, I need equations with x's and z's in. Okay, so I'm going to have to do a bit of a simultaneous equation. So I've got y is equal to, from over here, I've got y is equal to 6x minus 2x squared. Okay, and I've also got though that y from over here, okay, from over there we know that y is equal to 2z. And to find dx dz, okay, I've got to have an equation with x and z in. So if I combine those two and I do a substitution simultaneously, okay, if that's y is equal to that and y is equal to that, it must mean that 6x minus 2x squared is equal to 2z, but I've still got a bit of a problem because I've got to find dx dz, so I've got to get x on its own. Okay, so definitely say that. Dx dz. Alright, I thought there was a problem, and this time it wasn't my fault. There's actually a mistake in the question. You can go check in the memo, you'll see. The question should have been, I've probably got stuck here, find, so change the question please. The question should be dz dx. Okay, so the question should be dz dx. Okay, you can't actually do that with what the math that we've got. So I've got to get z on its own, and to get z on its own I simply divide by 2, so I get z is equal to 3x minus x squared, and therefore dz dx, okay, is going to be equal to 3 minus 2x. And that is the final answer, so just change the question. Okay, that should be dz dx. Right, go back, go finish off. Well, sorry, I couldn't see that. Let me just go over that again. My bad. Okay. So you had, should have been dz dx, and to get dz dx, okay, you get 6x minus 2x squared is 2z, divide by 2, and I get z is equal to 3x minus x squared, so dz dx is 3 minus 2x. Right, go back and finish the rest of the exercise please. Okay, and you can mark it yourself. Good luck, guys.